Yeah, good morning. So my name is Sanjeev. I am senior maths faculty in Perfect Academy. So last class we were seeing the integration. We just had seen the introduction part and one basic formula, and also we had seen that the integration is the reverse process of differentiation. Today we will continue that and we will solve more problems on that. Let's see. So last class we had seen the standard integration x raised n dx integration equals to x raised n plus 1 over n plus 1 plus c, where n not equals to minus 1, and also 1 by x dx equals to log x plus c, because the differentiation of log x is 1 by x. Now today we will see more and more problems on it. Let's see the first problem. Suppose we have to integrate root x into x plus 5 by x dx. Suppose we have to integrate this function. Then in all integration we just need to do that we have to convert it in the standard formula so that we can apply the integration formula. So this we can write it as integration. Now root x means x raised half and x means x. Here base is same, power should be added. So half plus 1, that is 3 by 2, plus this and this will get cancelled. We will get 5 by root x dx. Now this can be written integration x raised 3 by 2 plus 5 into x raised minus half dx. Now it is there in the standard form. We know we can use this formula to solve it. Apply it. X raised 3 by 2 plus 1 divided by 3 by 2 plus 1 plus 5 into x raised minus half plus 1 divided by x minus half plus 1. I am just using this formula to solve this integration. After simplifying we will get 2 by 5 x raised 5 by 2 plus this will come half and that will go up, that will make it 10 into x raised half plus one integral constant we can give. So this is the integration of this function. Let's see more problems on it. Now suppose we have a question to integrate this function x square plus 3x plus 4 divided by root x dx. Suppose we have to integrate this function. Again the same thing we have to do. What we can do, just separate it. So x square by root x, that is we will get x raised 3 by 2 plus 3 into x raised half plus 4 into x raised minus half. Now we can apply the standard formula to integrate this function. So that will be x raised 2 by 3 plus 1 over 3 by 2 plus 1 plus 3 into x raised half plus 1 over half plus 1 plus 4 into x raised minus half plus 1 over minus half plus 1 plus some integral constant. So let's simplify it. We will get 2 by 5 x raised 5 by 2 plus after simplifying it we will get this 3 by 2. So we can write 2 into x raised 3 by 2 plus here 8 into x raised half plus c. So this is the required integration of this function. Let's see next question. It's a good question. Let's see. Integration of x cube minus x square plus x minus 1 over x minus 1 dx. We have to integrate this function. Now here we can't divide like x cube by x minus 1, x square by x minus 1, because that will not give us the standard form. So what we can do, see here, the numerator can be factorized. Here we have x square common, take x square common, we will get inside x minus 1 and plus x minus 1 divided by x minus 1 dx. Now in this factor and this factor we have x minus 1 common, so take it out. So we will get integration of x minus 1 into x square plus 1 over x minus 1 dx. Now numerator we have x minus 1, denominator we have x minus 1, we can cancel it out and we will get integration x square plus 1 dx. And this is very easy to integrate. Applying the standard formula, we will get our integration like this. Okay, let's see next question. Now let's come to some trigonometrical functions. Suppose we have to integrate sec x into sec x plus 10x dx. Suppose we have to integrate this function. So what we can write here, after multiplying we will get sec square x plus sec x into 10x dx. Now we can separate it, integration sec square x dx plus integration sec x into 10x dx. Now we know the function 10x differentiation is sec square x, hence the integration of sec square x will be 10x. Similarly, the differentiation of sec x is sec x into 10x, so the integration of sec x into 10x will be sec x plus 1 integral constant. So this is the integration of this function. Let's see next question. It's a very good question. Sec square x divided by cosec square x dx. We have to integrate this function. So what we can do, sec square x we can write 1 over cos square x, and this cosec square x we can write 1 by sin square x using the trigonometrical identities. Now again, after simplifying, this sin square x will go up and this cos square x will come down. We can write like that. That is tan square x dx. After this, the tan square x, we don't know any function which can be used here to find the integration of tan square x. But using the trigonometrical functions identities, we can convert it into the standard one. We know one formula in trigonometry, that is sec square x equals to 1 plus tan square x. Hence from here tan square x will come sec square x minus 1. We can use it here. So this integration can be written integration sec square x minus 1 dx. Now sec square x integration we know that is 10x, because the differentiation of 10x is sec square x, minus dx integration is x plus c. So this is the integration of this function. Let's see next question. The question is saying integration 2 minus 3 sin x divided by cos square x dx. Now again we will use the trigonometrical identities. Here 2 by cos square x I can write to sec square x minus this function I can write 3 sin x by cos x into 1 by cos x dx. We have here cos square x, I have broken it up here, cos x into cos x. Now we can write 2 sec square x dx minus 3 into sin x by cos x we can write tan x, and 1 by cos x we can write sec x into tan x dx. Now the differentiation of tan x is sec square x, hence we can write it as 2 tan x minus 3. The differentiation of sec x is sec x into tan x, and integration of this will be 3 sec x plus 1 integral constant. So this is its difference integration. Let's see next question. Now the question is, if f dash x equals to x cube plus 1 and f of 0 equals to 0, then what will be the function f(x) that we have to find? See, f dash x we have x cube plus 1. So if we integrate both sides, then this we will get f(x) equals to x cube plus 1 dx integration, because the differentiation of this is this, so the integration of this will be this. Now if we integrate, we will get f(x) equals to x raised 4 by 4 plus x plus 1 integral constant. Now here one relation is given, this f of 0 equals to 0. So we can put it here, put x equals to 0 both sides, let this equation 1. Now f of 0, put x equals to 0, 0 by 4 plus 0 plus c. So from here we are getting c equals to 0. Whenever we are finding the integral constant, that type of integration is called definite integration. So here from the equation 1 we can have the function f(x) equals to x raised 4 by 4 plus x. So this is what the question is asking. Now let's see next. Now these were the very basics of the integration, means using the antiderivative and derivative idea to find the integration of any function. Now we will see the methods of integration. Generally we have three methods to integrate any function. That is, the first is substitution method, the second is partial fraction, and the third is by parts. We will see it one by one. The first one is substitution method, so we will see that first. Let's see what is this substitution method. In substitution method, we will substitute some variable. I want to explain it with the help of one example. Let's see. Suppose we have to integrate 2x sine x square dx. Suppose we have to integrate this function. Then in substitution method, what we do, we will assume some variable, the variable here x, we will assume here the function of x in such a way that will reduce the complexity of the integration, and that will come in the standard form. For example, here if we assume u equals to x squared, if x is a variable, its square will be also a variable only. We are assuming that as some function, some other variable u. So differentiating both sides, you will get du equals to 2x dx. Now this integration will be coming like integration 2x dx, from here 2x dx, that is equals to du, and here sin x squared equals to sin u. So we will get sin u du. So we can see, using the substitution method, our complex integration is reduced to a very simple one. Now we know the integration of this. The differentiation of cos x is minus sin x, so the integration of sin x will be minus cos x. So minus cos u plus c. At the end, we will replace this variable by what we have assumed. So we can write minus cos x square plus c. So this is the integration of this function, and this we have proceeded with the help of one example. Let's see more problems on it. Cos mx plus c dx. Suppose we have to integrate this function where m and c are some constants. Okay, so what we can do here, we can assume this as some other variable u equals to mx plus c. Differentiating both sides, we will get du equals to m only, m into dx. Because c is a constant, that differentiation will be 0, m is a constant, that will come out, and dx by dx, that is 1. Now this integration, after doing the substitution, converts to cos mx plus c is u into, what is this, dx. From here, what is the value of dx? That is du over m. So we can write here du over m. This m is a constant, that will go out, and we will left with cos u du. Now 1 by m, the differentiation of sine is cos, so the integration of cos will be sine. So we can write here sin u plus c. That we can write 1 by m into sin u. What is u? mx plus c. Here c is here, so we can assume some other constant c there. So this is the integration of this function using substitution method. The only work of substitution is to reduce the complexity of the integration, so that we can integrate the function easily. Let's see next question. Now we will see the integration of trigonometrical functions. We know the integration of sin x. Sin x integration is minus cos x plus c. We know the integration of cos x, that is sin x plus c. We know only these two. Now we will see the integration of all other trigonometrical functions. The first I will take tan x. Tan x dx. Suppose we have to integrate this function. We can use here substitution method. This integration can be written, tan is sin x by cos x dx. Here we can assume u equals to cos x, so that differentiating, we will get du equals to minus sine x dx. So from here, what is sine x dx? We will get minus du. So this integration can be written as sine x dx, that is minus du over cos x is u. So we can write minus 1 by u du integration, as the log x differentiation is 1 by x, so the integration of 1 by x will be log x. So minus ln mod of u plus some integral constant. So just put the value of u is here cos x, so we can write ln cos x mod plus c. Now this is minus sign, so it will get multiplied in the logarithm. We will get ln 1 by cos x mod plus c, and ultimately we will get ln mod sec x plus c. So this is the integration of tan x. We should remember it also. Integration of tan x equals to log mod sec x plus c. Similarly, we can integrate other functions. Similarly, we can have integration of cot x dx equals to ln sin x plus c. And integration of sec x, it will be ln mod sec x plus tan x plus c, and the integration of cos x we can write as ln cosec x minus cot x plus c. So this way we can integrate these functions. Now let's see some problems based on it. Now let's see more problems on the substitution method. The question is integrate this function 2x by 1 plus x square dx. So here very simple, we can assume this as u equals to 1 plus x square. So the du you will get 2x dx. So the integration will be du over u, that is ln mod u plus c, that is ln 1 plus x square plus c. Here we can remove modulus because this quantity will be always positive. Let's see next question. Suppose we have to integrate this function, then here what we can assume u equals to ln x, so that if you differentiate we will get 1 by x dx. So the integration we can write ln x as u squared into dx by x. From here we can write du. So that will be using standard formula this. So by substituting this value we can substitute ln x whole cube plus c. So this is the integration of this function. Okay, for today's up to here only. Thank you very much.